Good evening, all. First of all, I would sincerely like to thank the organizers and especially Dr. Jain sir for giving me this opportunity to present my work in front of this August gathering. Groundwater is the backbone of uh, water security of India, which is sharing the 60% of irrigation and 85% of the rural domestic supply. So this is an attempt to just give a glimpses of what academics is doing in securing this precious hidden resource, and a few of these slides would have all the outcomes, how we are finding the recharge potentials or the prolific zones for groundwater. Coming with the Maharashtra case study, where the Sahyadris, that is the Western Ghats, are playing a very vital role in hydrologic divide, where the easterly flowing and westerly flowing rivers are making a great impact on recharge and discharge water supply. Besides that, the terrain is basaltic terrain, which is a hard rock terrain, and these are the glimpses of how the filled photo or the filled varieties of basalts are, and they are very heterogeneous, being the very poor inherent porosity and also the fracture connectivity, the weathering of the basalt, and the pore spaces, vesicles present in the basalt are controlling the entire availability of groundwater. Now, I'll just talk about first the urban groundwater, where what is exactly happening through one of the research case studies. What we realized that due to the haphazard urbanization and also the maybe because of the land leveling and other activities, the original first order and second order streams have been vanished over the years. Also, a lot of thickness of soil and followed by the weathered zone has gone due to this leveling. So there are events which have increased in the city, such as flash floods, and also there is a remarkable decline in groundwater. So while this is happening, the suburbans, the areas which are not included in the corporation boundaries currently, are the main source of vegetable and other supplies to the city, applying a lot of chemical fertilizers and pesticides. So there was a study undertaken and showed that there is a remarkable increase in the nitrate content or concentration in groundwater. So while talking about the urban, also there is a lot of land requisition by the builders or the industry houses, which are actually leaving the original plan of the minor irrigation tanks or the water storage reservoirs. Now they are just like acting as a maybe recreational activities and water games. That's another sad part of the water resources happening to the urban part. Coming to the rural part of the Maharashtra, the main focus was to identify the groundwater prolific zones or recharge sites, and various watersheds were undertaken from the various parts. Now, what the story or the outcome was out of those various case studies was that we cannot treat all the watersheds one at the same. So, there should be a combination of the ground signatures that we are collecting combined with the RSGIS, the geoinformatics being added to it, or the various tools like vector overlay analysis, or some of the models like DSLR or drastic model should be wisely selected. So few of the glimpses I show here how the variety of watersheds were undertaken. The objectives were similar, but the data sets were different. So this is the Sangli Satara area where the watershed of Man River Basin was considered. These are the various themes where aquifer resistivity was also considered, and the groundwater potential zones were then finally highlighted. Similarly, this is another study where the delineation of groundwater potential zones of Upper Bhima Basin was undertaken. Here, the change was that there were a lot of satellite-based, remote sensing-based indices were taken into consideration because most of the area was under the highly undulated plateau, and reaching those areas was really difficult. So the remote sensing indices were quite helpful. Apart from that, there was also pre-monsoon and post-monsoon groundwater levels. A decadal change from 1990 till 2020 was taken into consideration, And then finally integrating those signatures, the groundwater potential zone was calculated. After the groundwater zone calculation, the another rural very popular exercise was undertaken is the prioritization. Once we consider the watershed, what are the areas or villages which are on priority to be taken for soil conservation and enhanced surface as well as groundwater availability. So there were different models and data sets based on the slope. Slope was the main influential factor to undertake such case studies. So these were all the watershed prioritization taken into consideration depending on the mainstream profiles also, and various data models and the methodology was being considered here. The formulas were or maybe employed, and also the morphometry was taken into consideration. How much is the density, how much is the frequency of first and second order streams, and how much is the runoff. If we are suggesting some water harvesting structures, then whether we have a sufficient runoff to the structure. So once we are finding the prioritization, we then followed the groundwater site suitability. Like all the structures cannot be in all over the terrain. So there should be some criteria where we are planning the continuous contour trenches or the percolation tank or the cement bunds. So this was undertaken. Now there was another question that we are storing the water, but is someone monitoring that how much impact it has made to the aquifers? Really the aquifers are getting benefited, the real recharge is happening to the aquifers, and is there any quantification that this much water has been in groundwater level has been increased due to the water harvesting structures? So this study was undertaken, the impact assessment, where the isotope signatures of rainwater, then the water in these surface structures, and the dug wells and bore wells were taken into consideration. Also the analysis was done where resistivity was measured before the structure and after the structure. Is there any moisture increased in that area? And then it was realized that the ground data is not available. There is a data paucity, and what can be done in the watersheds in the areas which are remote, which are virgin, or the areas with paucity of data. Then recently a study has been undertaken using the gray satellite data, which is helping understanding the stressed aquifers, also understanding the declining groundwater, and also the storage change annually happening to the subsurface formation. So one case study of Jalgaon is taken deliberately because Jalgaon is under a lot of alluvium. So hard rock and alluvium combination, how it is responding to this gray satellite data was taken into consideration. So it was found that 1.2 to 2.5 meter decline in groundwater level is happening. So this was attributed to the banana and the other crops which are very often taken in that area. So here I conclude my study that the key takeaways are that the basaltic unconfined aquifers are annually replenished. So they are phreatic, every rainfall is annually replenishing. So if we are managing it, there won't be a water stress condition. Also followed by the significant drinking water demand is met through these large diameter duct wells, tapping phreatic aquifers, especially in rural and semi-urban regions. These aquifers unfortunately are highly vulnerable to the seasonal groundwater decline, particularly during the summer months, causing reduced yield and rendering many water supply schemes unsustainable. So there should be a source sustainability study. The State Groundwater Department should undertake such studies very frequently and very deliberately. Also, there is a groundwater demand management must be given equal emphasis alongside the augmentation and artificial recharge. The impact assessment should be there, that how much actual recharge it's making. And also there should be a noticeable thing to be kept in mind, that the benefits mostly are localized because of the poor fracture connectivity in hard rock terrain. I would also like to draw your attention to this very peculiar phenomena that under the natural equilibrium conditions, the groundwater table is replica of the terrain. But recently, maybe a decadal change, during the decadal observation, what I have realized is that in the runoff zone, the wells go dry, and they are mostly from February onwards, they are fed with either the tanker water or nearby a dam or other water. So it is also making the groundwater changes, maybe physico-chemical changes. When it comes to recharge area, there is a lot of fluctuation in groundwater levels. So to secure the water, what farmers are doing, that they are pumping this water from dug wells and bow wells and filling the farm ponds. So the water which is very safe underground, which is protected from evaporation, is directly exposing to evaporation. And when coming to the discharge or the storage zone, water availability is there. There is no depletion of groundwater levels, but there is a lot of agricultural practices which are using chemical fertilizers and the other things, and the pesticides which are making high nitrate and the other fluoride or other concentration, both from the geogenic and anthropogenic sources. And there, what I have observed is that there is a filtration plant fixed in a particular village, and even though the water is available, it is not suitable for drinking. So the way forward lies in basin scale maybe study. Also, there should be updating recharge maps very frequently. The technicality or a very sound technical guideline should be there for water harvesting structures, and there should be a strong interconnection between all the groundwater and the other departments. There should be a strong interconnectivity. With this, I just hope I'm completed in time. Thank you.